4G LTE long-term evolution, represents a major leap in mobile telecommunications, moving away from the hybrid voice/data systems of 3G toward a fully all-IP, Internet Protocol, architecture. While 3G networks still relied on circuit switching for voice calls, 4G LTE was designed from the ground up to treat everything including voice as data packets. Key architecture components in the 4G LTE model: the network is simplified into two main parts that interact with the IMS core for voice services. E-UTRAN, the radio access network, consists of eNodeB, evolved NodeB, base stations that communicate directly with your phone. EPC, evolved packet core, the brain of the network, which includes eNodeB, mobility management entity, handles the signaling and tracks your location as you move between cell towers. SGW, serving gateway, routes data packets between the base station and the core. PDN-GW, packet data network gateway, the exit point that connects the mobile network to the external internet or the IMS core for voice. Here's a structured explanation of 4G LTE and the key differences from 3G, UMTS/UTMA. I'll break it down into architecture, technology, performance, and services. What is 4G LTE? LTE, long-term evolution, is a fourth-generation mobile communication system designed to provide high-speed data and broadband mobile internet, low latency for real-time applications, all-IP network architecture, no circuit switch domain for voice. High spectral efficiency and flexible spectrum usage. Key goals of LTE: 1. Peak data rates, downlink, up to 300 Mbps, uplink, up to 75 Mbps. 2. Reduced latency, 10 ms, air interface. 3. Simplified network architecture with flat IP-based core. 4. Seamless mobility across cells and inter-RAT, radio access technology. LTE architecture, evolved packet system, EPS. LTE is divided into radio access network, E-UTRAN, and core network, EPC, evolved packet core. E-UTRAN, radio access, eNodeB, evolved NodeB, combines functions of 3G NodeB plus RNC, handles radio resource management, scheduling, and mobility, connects directly to EPC, no separate RNC, uses OFMA, downlink, and SCFDMA, uplink, for high spectral efficiency, supports MIMO, multiple input multiple output. In the 4G LTE architecture, the eNodeB, evolved NodeB, is the most visible part of the network. It is the hardware located at the cell site, the cell tower, that communicates directly with your mobile device. Unlike 3G, where the base station was a relatively dumb component controlled by a separate radio network controller, RNC, the 4G eNodeB is intelligent. It handles many control functions locally to reduce latency and speed up the network. Key responsibilities of the eNodeB: radio resource management, RRM. The eNodeB is the air traffic controller for radio frequencies. It decides which phone gets to transmit data at which millisecond, how much power your phone should use to save battery while staying connected, which frequency blocks, resource blocks, are assigned to your session. Header compression and encryption. To make data travel faster over the air, the eNodeB compresses the IP headers of your data packets. It also encrypts the wireless signal so that your calls and data cannot be easily intercepted between your phone and the tower. Handover control. The X2 interface, one of the most critical roles of the eNodeB, is managing handovers. If you are in a moving car, the eNodeB you are currently connected to talks directly to the neighboring eNodeB via the X2 interface. They hand off your connection to each other seamlessly so your call doesn't drop. Connection to the core, the S1 interface. The eNodeB acts as the bridge between the wireless world and the wired fiber core. It uses the S1 interface to talk to the evolved packet core, EPC S1 modem, send signaling, control, info to the mobility management entity. S1U, sends your actual data, user plane, to the serving gateway. Comparison, 3G versus 4G eNodeB feature: 3G NodeB, 4G eNodeB intelligence low, controlled by RNC, high, autonomous, network latency higher, extra hop to RNC, lower, direct to core, handovers managed by RNC, managed between eNodeB S, X2, architecture hierarchical flat/distributed. The eNodeB and IMS. When you make a VoLTE call, the eNodeB recognizes the voice tag on your data packets. Thanks to instructions from the PCRF, policy and charging rules function, in the IMS core, the eNodeB gives your voice packets a QCI1, quality of service class identifier, rating. This ensures your voice is transmitted instantly, even if the tower is busy with other people downloading videos. BEPC, evolved packet core, key elements, EPC node role modem, mobility management control plane functions, session management, paging, entity, authentication user plane, routes data packets, mobility anchor for intra-LTE SGW, serving gateway, handovers, connects LTE to internet or other IP networks, allocates IP PGW, packet gateway, addresses, QoS enforcement HSS, home subscriber server, subscriber profile and authentication, from 3G HSS, PCRF, policy and charging rules policy control, QoS. Charging rules function, the evolved packet core, EPC, is the brain of the 4G LTE network. Its introduction was revolutionary because it replaced the old, fragmented 2G/3G core with a simplified, all-IP, Internet Protocol, framework. In the EPC, voice and data are treated equally as IP packets, which allows the network to be much faster, flatter, and more efficient. The four main pillars of EPC. The EPC is composed of four primary functional blocks, each with a specialized role in managing your mobile session. 1. MDAM, Mobility Management Entity. The MDAM is the control plane manager. It doesn't handle your actual data, like your Instagram feed, instead, it handles the paperwork. Role, it authenticates you when you turn on your phone, tracks which cell tower you are near, mobility management, and chooses which gateway should handle your traffic. Analogy, the air traffic controller who gives the pilot permission to fly but doesn't fly the plane. 2. SGW, Serving Gateway, the SGW acts as the anchor point for your data connection. Role, as you move between different eNodeB towers, the SGW stays put, ensuring your data stream isn't interrupted. It routes and forwards user data packets between the tower and the rest of the core. Analogy, a local post office that collects mail from different neighborhoods and sends it to the main sorting center. 3. PGW, PDN Gateway, the PGW is the exit/entry point to the outside world. Role, it assigns your phone an IP address and connects the LTE network to external packet data networks, PDN, such as the Internet or the IMS core for voice. It also handles policy enforcement, making sure you don't exceed your data cap. Analogy, the border customs office that checks where you're going and makes sure you have the right visa, data plan. 4. HSS, Home Subscriber Server, as discussed in our IMS look, the HSS is shared between the EPC and IMS. Role, it is the master database containing your SIM card info, service profile, and whether or not you've paid your bill. Analogy, the central DMV database that holds your driver's license and registration. Key interfaces in the EPC to make the system work. These components talk using specific high-speed interfaces. Interface Connection Protocol Purpose S1 MDAM eNodeB left right arrow MDAM S1 AP Signaling, Control, Messages. S1U eNodeB left right arrow SGW GTPU carrying the actual user data. S5/S8 SGW left right arrow PGW GTP data transfer between gateways. S6 a MDAM left right arrow HSS diameter authentication and user profile lookup. The EPC and voice, IMS, the EPC by itself cannot handle a traditional phone call. It only knows how to move data. This is why the IMS core is necessary. When you make a VoLTE call, 1. The MDAM sets up a high priority bearer, a dedicated data lane. 2. The PGW routes that voice data to the IMS core. 3. The PCRF, Policy and Charging Rules function, tells the EPC to give that specific voice data a QCI1 priority so your call doesn't lag. LTE Architecture Diagram, simplified, plus dash dash plus internet plus dash dash plus dash dash plus PGW SGW MDAM plus dash dash plus dash dash plus eNodeB plus dash dash plus UE, mobile device. Key features of LTE feature description. All IP network voice and data are delivered over IP, VoLTE for voice, high data rates up to 300 Mbps DL, 75 Mbps all low latency 10 ms air interface, 20 to 30 milliseconds end-to-end flexible spectrum can operate in multiple frequency bands, 700 to 2600 MHz, etc. Advanced Radio Tech OFMA, SCFDMA, MIMO, carrier aggregation flat architecture eliminates separate RNC, simplified signaling. Key differences between 3G and 4G LTE feature 3G, UMTS/UCMA, 4G LTE, E-UTRAN/EPC, circuit switched plus packet core network all IP packet switched, EPC, switched voice circuit switched via MSC VoLTE, voice over IP, data rates 384 kbps rightward arrow HSPA plus 42 Mbps DL 300 Mbps, all 75 Mbps latency 100 to 150 milliseconds 20, 30 ms, end-to-end, radio technology UCMA/HSPA OFMA, DL, SCFDMA, UL. MIMO network RNC plus eNodeB eNodeB, flat, no RNC, architecture QoS management limited PCRF based policy control, QoS guaranteed mobility soft handover supported hard handover with LTE handover optimization high speed internet, VoLTE, video call, services voice, SMS, low speed data streaming, gaming. The role of IMS in 4G. Since 4G LTE does not have a native phone line, circuit switch, for voice, it relies entirely on the IMS core to handle calls. When you make a call on 4G, it is treated as a high priority data stream, VoLTE. The PCRF within the IMS framework ensures that even if you are downloading a large file, your voice call remains clear and uninterrupted by giving those specific packets VIP status. Connection to legacy systems as shown in the reference diagrams above, 4G LTE is designed to be backward compatible. Through the MGCF, Media Gateway Control function, a user on a modern 4G LTE device can still seamlessly call a legacy GSM phone or a landline on the PSTN. Summary of 3G rightward arrow 4G LTE evolution. 3G is voice-centric with added data, LTE is data-centric, with voice over IP, VoLTE. LTE removes circuit-switched networks, enabling a flat IP-based architecture for scalability. LTE introduces advanced radio tech for higher spectral efficiency and capacity. LTE provides high-speed, low-latency connectivity, making it suitable for multimedia, streaming, and real-time applications. Here's a side-by-side architecture comparison of 3G, UMTS, vs 4G LTE, E-UTRAN plus EPC. This highlights the differences in radio access network, core network, and voice/data handling. Side-by-side architecture, 3G vs 4G LTE plus dash dash plus plus dash dash plus 3G UMTS 4G LTE plus dash dash plus plus dash dash plus user equipment, UE, user equipment, UE, UU, bookma, LTE UU, OFMA/SCFDMA, VV plus dash dash plus plus dash dash plus eNodeB eNodeB, 3G base, 4G base station, station, plus dash dash plus dash dash plus plus dash dash plus dash dash plus IUB S1 madam/S1 UVV plus dash. Plus dash dash plus RNC EPC radio network evolved packet controller core network. Plus dash dash plus dash dash plus plus dash dash plus dash dash plus IUCS/IUPSV plus dash dash plus dash dash plus plus dash dash plus dash dash plus MSCS madam, circuit and mobility management call control. Plus dash dash plus dash dash plus 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 MGW/SGW media gateway serving GW plus dash dash plus dash dash plus plus dash dash plus dash dash plus PSTN/ISDN user plane VV plus dash dash plus plus dash dash plus PSTN/ISDN PGW plus dash dash plus packet GW to internet/IP plus dash dash plus V. Internet. Shared databases, 3G, HLR, VLR, AUC, EIR4G, HSS, PCRF, policy and charging. Key differences highlighted aspect 3G UMTS 4G LTE eNodeB, flat, OFMA DL, SCFDMA radio access eNodeB plus RNC, bookma/HSPA UL, MIMO core network circuit switched plus packet switched all IP packet switched, EPC, voice ES voice via MSC VoLTE, IP voice, data rates up to 42 Mbps, HSPA plus, DL up to 300 Mbps, UL 75 Mbps latency 100, 150 ms 20, 30 ms mobility hard handover optimized, direct madam soft handover via RNC management. Control QoS/policy limited PCRF managed QoS and charging hierarchical, eNodeB rightward arrow RNC rightward arrow architecture flat, eNodeB rightward arrow madam/SGW/PGW, MSC/SGSN. Summary, LTE eliminates the RNC and circuit switch domain, creating a flat, all-IP architecture. eNodeB combines eNodeB plus RNC functions, reducing latency and improving efficiency. LTE supports higher data rates, low latency, and IP-based multimedia services. 3G is voice-centric with added packet data, while LTE is data-centric with VoLTE for voice.